On New Year's Day, 1995, a wall of water hit an oil platform in the North Sea. It measured almost 26 meters tall. The physics of the time said that wave could not exist. By the end of this, you'll understand why scientists spent 100 years calling these waves a lie, and why the ocean finally proved them wrong. Let me take you back a little. For centuries, sailors came home with the same story. Out of a calm sea, a single mountain of water would rise, twice as tall as anything around it. A wall, they said, with a valley in front like a hole in the ocean. And for centuries, the experts just smiled. They wrote it off. Tired eyes, tall tales, panic in a storm. The math simply didn't allow it. So the stories were filed away as folklore. You can almost feel why they doubted it. Waves are supposed to average out. Big ones, small ones blending into a gentle roll. The idea of one freak giant, alone, out of nowhere, it broke the rules. But here's the question that kept nagging. Why did so many ships just vanish? Large ships. Steel ships. Ones built to survive anything the sea could throw. Between the 1970s and 1990s, dozens of big cargo vessels were simply lost. No maidai. No wreckage that made sense. Ships longer than 2 football fields gone in minutes. The official reports blamed the weather. Bad luck. Human error. But some investigators noticed a pattern they couldn't shake. The damage looked wrong. Like something had struck from directly ahead, high up, all at once. Still, without proof, it stayed a theory. You can't build science on a sailor's memory. You need a measurement. A number nobody can argue with. And that brings us to the twist. Because the standard model wasn't just cautious. It was confident. It predicted a wave that tall should appear maybe once every 10,000 years. Once in 10,000 years. That's how rare the math said it was. So rare you could sail your whole life and never see one. So rare it was basically impossible. So when the sensor on the Dropner platform recorded that giant on New Year's Day, engineers assumed it was a glitch. A broken instrument. A number to be deleted. But they checked. And checked again. The laser under the platform had been aimed straight down at the water. It was measuring the true surface second by second. The reading was real. In an ordinary storm, a single spike had risen far above its neighbors. The waves around it were around 12 meters. This one nearly doubled them. Here's what makes it hit home. Imagine standing on a beach where every wave comes up to your knee. Then one wave rises to your chest, alone, and drops back. That's the scale of what happened, but with an 8-story building. Expected once in 10,000 years. Measured on a quiet holiday, on a working platform, with a laser watching. The gap between what science expected and what the ocean did was enormous. And suddenly, every dismissed sailor's story looked different. The folklore had a number now. The Dropner wave became the first rogue wave that nobody could deny. So the real question became this. If the old model was so wrong, what were they missing? How does a calm sea build one giant, then hide it again? This is the core of the whole mystery. And scientists are still working on it. But a few ideas have gathered real evidence, and they're beautiful once you see them. The first idea is called constructive interference. The sea isn't one clean wave. It's hundreds, moving at different speeds in different directions. Most of the time, they cancel each other out. But every so often, by pure chance, their crests line up in the same spot at the same instant. They stack, one on top of another, adding their heights together. For a moment, you get a giant. Then they drift apart and it's gone. The second idea is stranger. Some waves may steal energy from their neighbors. In certain conditions, a wave can pull strength out of the waves around it. It grows as they shrink. Scientists call this a nonlinear effect. In lab tanks, they've actually watched it happen. A small wave feeding on others, swelling into something that shouldn't be there, then collapsing back into the crowd. And there's a third piece. Ocean currents. When big waves run into a strong current flowing the other way, the energy gets squeezed together. It piles up. Certain coastlines see rogue waves far more often for exactly this reason. So which one is the true answer? That's the honest part. Scientists still argue about it. It may be all three in different places on different days. Now, here's what most people get wrong. They think a rogue wave is just a really big storm wave, the kind you'd expect in a hurricane. But that misses the whole point. A rogue wave isn't defined by height alone. It's defined by surprise. It's a wave at least twice as tall as the waves around it. That means you could get a rogue wave in a moderate sea, a ship in manageable conditions, then one freak crest appears. The crew never saw it coming because everything else looked normal. And people assume they're incredibly rare thanks to that old 10,000-year number. But once satellites started scanning the oceans, that idea fell apart completely. In just 3 weeks of scanning, one space mission spotted more than 10 of these giant waves around the world. Not once in 10,000 years. All the time, somewhere out there. That changed everything, because it meant the ships weren't unlucky. They were meeting something the science had refused to plan for. So what did all this actually change? Quite a lot, and you'd never know it from land. Oil platforms are now built to survive impacts the old rules said couldn't happen. Ship designers study these waves seriously instead of laughing them off. Wave models have been rewritten from the ground up. There are even early warning efforts now. Researchers are trying to predict the sea states where rogues are likely. Not the exact wave, but the dangerous conditions. A weather forecast for giants. And for the families of every ship that vanished without explanation, there's something quieter here. A possible answer. The sea wasn't lying, and neither were the sailors. So let's loop back to that platform on New Year's Day. A wave that physics said appears once in 10,000 years, caught on a working sensor on an ordinary morning. It turned a century of folklore into fact. We now know rogue waves are real and far more common than anyone believed. We know they can rise from a calm sea and vanish in seconds. But here's the wonder I can't let go of. Right now, somewhere out on the open ocean, the waves are quietly lining up. And no one on Earth can tell you exactly where the next giant will rise.